Okay, so the sequences that we learned yesterday, just kind of recapping, right? We talked about two different patterns in particular, right? We talked about what it means for a sequence to be arithmetic, right? Arithmetic we can identify when we're adding or subtracting by that same number. And the other pattern we looked at were geometric sequences. Remember, we can recognize if a sequence is geometric by if that common ratio, right? By multiplying or multiplying by a fraction, right? So more into detail, we're going to look at arithmetic sequences, okay? So this is kind of a more in-depth arithmetic. This is a more in-depth kind of lesson on what it means and how to write the equation of an arithmetic sequence. So what you see here, okay, this top line, we read this. A sub n is equal to a sub 1 plus parentheses n minus 1 times d. Okay, so this is the generic formula or equation that we're going to use in order to write the equation of an arithmetic sequence. All right, so let's kind of break down these little pieces here, all right? So this a sub n, this is, if we want to think about how we talked about, how this is closely related to a linear function, right? We talked about y equals mx plus b. This would be the y part of it. So this is referred to as an output. Remember output, when we put a number in, what comes out? But this is the actual number in the sequence. Okay, so when we see a pattern of numbers, these are the actual numbers that, you see actually written out. So these a sub n's, it's kind of a fancy way to say it, but it is just the number of the sequence there. This a sub 1, so notice how we see these same a's. So this is how we're going to name the sequence. Okay, so here in this particular case, we're just naming the sequence a. So this is a sub some number, but in this particular case, this is a sub 1. So what this actually means, this is the first number in the sequence. So remember, sequences start with term 1, and that's what this wants right here. This is wants the very first term of the sequence. Remember when we wrote linear functions, we need to know where this starts, right? So sequences start with first term, so that's the first number we've got to find. A sub 1 means the first number in the sequence. This n, okay, is directly related to this n, right? Sequence a sub n, well, this is the term number. And, when we talked about this yesterday, these are your counting numbers. So this is your term number. And we're going to use this a lot, when we start having to predict, what would be the 100th term of a sequence, okay? So that's what this number is going to represent. In the nth term, or what number of the sequence are we referring to? The 1 is just going to be a whole number. We could be going into more detail with that, but just understand that, this is the formula we're going to use. But the next part of it, I feel the most important part of the equation is D here, okay? And the D, which hopefully kind of thinking about what we did yesterday, this is a common difference. Okay, so again, this is the formula we're going to use. This is kind of the generic equation for how to write an explicit. This is something you also refer maybe here. This is the explicit equation, EXPL. Okay, this is an explicit equation for our arithmetic sequence. But in the end, okay, you need two things in order to write the equation of this of the sequence here. So remember when we talked about writing the equation of a line, you needed two things. Where did it start and how was it moving, right? Remember we needed M and we needed B. Sequences, talked about, or arithmetic sequences actually, told you took on the same exact thing as a linear function, right? It's a constant rate of change. It is the same thing. You need the same two things. Where does it start, right? Sequences start with A1, or the first term. And how is it moving, right? In this particular case, we're going to call it D, common difference. So it's literally the same exact thing we did earlier in the semester, but instead of finding M and B, you are now finding A sub 1 and letter D. All right, so I got 3 examples here. So if we look at this first sequence, hopefully we should be able to recognize that this is arithmetic, right? We are using that same number to get from one term to the next. Term 1 here is 12. Term 2 is 16. So remember, if you can't see the pattern right away, take 2 consecutive numbers that you see and just subtract them, right? It's a common difference, so we need to subtract the numbers. Well, 16 minus 12 is 4. So it looks like the common difference here is 4. And you can see that in between each successive term here is that letter, or is that number 4. So simple enough, that is our common difference. That is letter D, right? So remember, you need 2 things. You need where does it start and a common difference. Well, we just found the common difference, right? In the other part, where does it start? Sequences start with term 1, and it should be simple enough to see that, well, this guy here is term 1. Okay, so this is your A sub 1. Okay, so now, simple enough, we're going to put these pieces together. We're able to write an explicit equation for our sequence here. So we have sequence A sub whatever number we want is equal to, well, that A sub 1 that we just found to be 12 plus n, whatever term we want, n minus 1 times that common difference, right? The common difference here, sorry, my camera. The common difference here we found to be 4. All right, so we can see we got parentheses there. We've got a little bit of distributive property we can kind of clean up and take care of. So I'm going to distribute this 4. So A sub n is equal to 12 plus 4n minus 4. We've got like terms with the 12 and negative 4. So A sub n is equal to, well, 12 minus 4 is what? 8. So we have 4n plus 8. Okay, so this is the explicit equation that is 100% unique to that sequence that we just, during our first example. Okay, so, why do we need this? Okay, so you will be asked different questions like, you see the sequence and it could ask you, what is the, the 50th term of this sequence, right? So I don't think we have the time or energy or even the want to use this plus 4 and just keep adding 4, plus 4, right? All the way up to the 50th term, right? It's kind of redundant. We don't need all of that. So that's why we have an equation. So if I want to find the 50th term, okay, so if I'm searching after the 50th term, what color do I want to use? Let's use green. Okay, so remember this sequence A. So if I want 50, right, term number n, I want term 50. You're going to see it written like this. A sub 50, meaning the 50th term of the sequence, is equal to, right? So that same n, right, these are linked together. This n and n mean the same exact thing. It's the term number. We want specifically term number 50. So it's that common difference of 4 50 times, right? And, well, we simplified out to say plus 8. So if we multiply this out, 4 times 50 is, what, 200 plus 8 is 208. Okay, so this was the whole goal of this, being able to write an explicit equation to be able to kind of see what's going on in future terms of a sequence, and this is what we've got. So this A sub 50 equals 208 means, well, during this sequence A, right, we're just going to call all sequences A. Sequence A, the 50th term is 208. And if we were to drag this sequence out all the way out to term 50, you would see that we would run into number 208. All right, so I'm running short on kind of cap time for this video, so I'm going to stop this video here. If you're good to go, you understand what's going on after this one example, awesome, move on to the assignment. If not, I'm going to go through 2 more examples with you.